gathered here for a case study discussion on how to design a safety airbag control system using embedded system. So the modern life are facing with more of a vehicle pollution, so where safety becomes more concern. So earlier the pollution detection was not much accurate. So here we are going to design a better airbag control system. So in the traditional methods, they used seat belts and other vehicle structures to prevent the damage. But those were not sufficient to meet our expectation. So we are going to design a better airbag control system such that the collision is detected earlier and the safety is provided. So I'll give you 5 to 10 minutes, discuss among yourself and get me a good solution to design a good airbag control system using our embedded system. So hope you have completed your discussion. You can start providing the solution now. So yes.
So coming to the problem statement, we are going to build an embedded system where in a future world many vehicle collisions has been happening for a long time. So we're going to produce or innovate a airbag deployment which should deploy within a 5 to 10 milliseconds. So the airbag should be instructed or constructed like it must be working even in extreme weather conditions like sensor fault or any weather conditions like rainy days or something. So that is a basic idea or momo of our problem statement.
So coming to the architectural system for our problem statement, we'll be needing only 4 major components. So that is, the first one would be the sensors, then comes the control unit, and then the actuators, and finally the battery system. So coming to the sensors, we'll be using accelerometer, gyroscope, and the pressure sensor. So accelerometer will be detecting the motion. Gyroscope will be detecting at which angle the accident is actually happening, and then the pressure sensor will be measuring the pressure at which point the accident is happening. And coming to the control system, we'll be actually using ECU, that is electronic control unit, where it will process the data which has been taken from the sensor. So it will decide like whether it's just a bump, whether it's just a speed breaker, or it's actually an accident. So it will be processing there. And finally, the next part is actuators. So here is the main part, like the airbags and all will be kept here only. So if an accident takes place, so a pyrotechnic device will be set there. So basically what it does means it will just give a controlled explosion. So after that, the last one would be the battery system. So it will be using capacitors. So for the backup plan, if the battery drains out, the capacitors will be taking over and it will take care of the battery management system. So this is the 4 major components for the architecture of the system.
What will be the challenges faced while designing this type of system?
So let us see the challenges in real world. First of all, the system accelerator of sensor motor. To detect the accidents before the time, we want to rush the airbags to open milliseconds. So we use the sensors like accelerometers and the impact sensor to detect the climate vibrations, noise pollutions, and so the system want to identify the real conclusion, avoiding the false triggering system. The sensor want to detect the people where we have accidents occurs. So the system want to monitor the person is an adult or empty gap or the people who are lived in the accidents. So protect the airbags to the people away from the accidents.
And the solution design. The system works with multiple sensors, ECU and actuator, and The first thing, we need to continuously take the data. So we use multiple sensors like gyroscope, accelerometer, and the pressure sensors, etc. And we need to use filtrate to remove the noise. So once it exceeds the threshold value, the impact should be happening within short duration. And next, to get rid of the false triggering during the crash time, we use multiple sensors. And also, it is to design for the hard real world real world things, because a lot of the obstacles may occur, so the airbag should be deployed within a second. And also, we use backup capacitor if the battery fails. And finally, if crashes happen, there is nuisance signal to the impacted, so that the time the airbag deploys within a milliseconds.
So what will be the step you have taken if a false trigger is occurring? How to overcome the false trigger?
So we use multiple sensors. We continuously taking the data from the sensor. If there is minute fault, it is the airbag will deploy within seconds.
So I'm going to discuss about the timeline and errors which we handling in this. So the timeline is, we need to first decide the process. First we need to process it like to 1 to 2 milliseconds, and next we want to decide that also less than 1 milliseconds. So next with the process is, after we decide, we go to the failures. So this will triggers for same 1 to 2 milliseconds. So first we choose the timeline, next we need to handle the failures. So we have the battery power, less battery power, or we have any failure issues like in water or rain, or we have any some false triggers. So for these all we have the backups, like power backup or false trigger. We have some we need to, for false trigger we need to check multiple times. If the output is ready, you need to check it is 2 or 3 times, multiple times to it is okay, this condition is okay, then after only we give the output for that.
Thus, as per our discussion, with the help of multiple sensors and as Jenny told, ECU and other various parameters, we can easily design an airbag control system which can detect the collision efficiently without any error, so that the human life can be saved.